So in this video, I'm going to be showing you guys some similar problems you have to understand for the exam here. Whatever figure you're given with, here I'm going to use a cylinder. So for example, let's say you start with a cylinder. I'm going to draw it out and really just try to understand the idea here. And what I'm going to do is I'm going to call this radius here, I'm going to call it R0, just indicating that it's the initial radius. And let's say I initially fill it up, right? And let's just say that this is the height h. I'll call it h0 just to indicate that it's the initial height. And what I can say is the initial volume is going to be pi times R0 squared times h. So this right here tells you the initial volume. That's like what you're starting with, right? Where the zeros just mean the initial. It's like they're all known values, right? It could be anything. And then you might get some information that says something about, let's say, the volume or the height, something like that. Let's say you got information about the volume. Like, let's say you got that the volume is going down at let's say 2 meters per second or something, right? You need to understand that, let's say if you are going down at 2 meters cubed per second, the amount of volume you'd be losing every second would be minus 2t. You'd have to rewrite this as minus 2t. So let's say I wanted to write down a volume equation that represents I'm initially starting with this much fluid. Okay, so that's going to be this value here. Okay. So the volume in terms of time is going to be the initial amount that you start with. And then every second, it's going to go down by let's say 2 meters cubed per second. Okay. And if you imagine, let's say we actually, let these values become numbers. Let's say if, right, if the initial height was, let's say, 5, for example, and let's just say the initial radius was 2, if you were to plug both those into the original equation, you would actually get 4 times 5, that's a 20, so you'd actually get 20 pi minus 20. Or you'd get 20 pi minus 2t. Okay. So again, you need to be able to understand if you have some fluid, right? If you're draining fluid out, it's going to be a minus something. If you're adding fluid in, it's going to be plus something t, right? And you got to know that, but also understand if you're dealing with a height, right? So let's say you wanted to, I don't know, express the height in terms of t here. So let's say I wanted to know let's say I wanted to know what h of t was. Can you solve for h of t? Okay. So given this information, if you, so given this information, if we know that the volume's going down by 2 meters cubed per second, how would that, how can you solve for just the height? Okay. So to solve for the height, we're really just, we're looking at the initial height. And the first thing you want to do is you want to write down this pi r squared h. Okay, so the pi r squared h, yeah, so this one is a little confusing here. The pi r squared h, here h is a variable. So let's say I wanted to solve for the height in terms of time. I know that the volume of, you want to be visualizing this, right? So you want to be imagining this volume going down. So after a second, maybe you're here. After another second, maybe you're here, et cetera, et cetera. So as time passes, this is the volume equation. So no matter how much time passes, you're going to always have the equation of a cylinder. So pi r squared h, you can set pi r squared h equal to that 20 pi minus 2t. And then I know that the r is always the same here. Here, the value of r was 2. So I would have 4 pi h is always going to equal 20 pi minus 2t, divide by 4 pi, and then now I get the function for h of t. So h is going to be the same thing, just divide both sides by 4 pi. So that would cancel out here. So, the height in terms of time would be this value right here. 20 pi minus 2t divided by 4 pi. So yeah, that's the thing. So, as far as like the steps, like you really gotta, for these problems, again, what's the summary? Make sure you're drawing out the right picture. Like if you ever see a problem where you have some initial amount of fluid, always make sure that you're drawing it out like this. Try to visualize, as time passes, draw out a few situations where the fluid's going down. And you got to understand how to write down the equations if, let's say, a volume is draining, like this situation here, or if it's being filled up. And then understanding how to solve for the height of some fluid at any given moment. And you have to understand that this volume, this value here, is going to be a cylinder no matter what time you're at. So that's the idea. So you got to make sure that you can understand this problem, but be able to do it with, let's say, any type of figure, right? Okay. All right, guys. Gonna go on to the next thing here. Okay. So next thing, guys. Next thing. Okay, guys. Next thing. Here we go. Again, you gotta be able to graph a piecewise function. So I'm not gonna tell you which type it is, but for example, here's just, an example of what you need to know how to graph, right? Okay. So let's say you had something like this. Okay, so, given a piecewise function, can you graph this on an XY chart? Again, you got to remember that this part of it here tells you which values of x you're allowed to plug in, and same thing here. It really tells you where to stop or end. If x is greater than 0, remember the procedure is always plug in the boundary points, like every time. That always tells you where the graph is starting and ending. It helps if you read this in words. Here, I want to graph f of x equals x squared from 0 to infinity. And then I want to graph y equals the square root of x from minus infinity to 5, right? Okay, so now I'm going to make an xy axis here. If I plugged in 0, that's going to be an open circle because there's no equal sign. So I'm going to make the open circle here. And then I can plug in any value I want that's more than 0. So I'm going to plug in 1, let's say. That's going to give me the 0.11. And then you should understand, that's just a parabola. You should know that it curves up like this. Also understanding that if I were to graph the entire thing, it would look like this. But because it's x greater than 0, that part gets deleted. And then, like square root of x when x is less than or equal to 5. So again, this one kind of overlaps, right? So I would have 1 Let's change this one actually, so it makes more sense. I'm going to change this guy to -2 here. So let's say I'm going to graph this thing like the square root of x for values of x that are less than or equal to -2. And actually, this guy here, yeah, the square root of x function here wouldn't even work for this because you can't plug negative values. So you got to make sure that you have a function here where the negative values are allowed. So I got to change this just a little bit here. So I'm going to change this to a 5. Okay. So let's say, so this works now. So something like this. So if this thing's going to start at -5, 0. All right. And then any value of x that, you keep increasing the x, you're going to get a y value. Like, for example, if I were to plug in -4, I'm going to get 1. And if I were to plug in -2, I would get the square root of 3. And then that's it. You're stopping at -2, right? And that would be like a line segment, like right there. The graph would start at that dot right there and end at -2. It would end at -2, comma, the square root of 3. And this would be like -5, 0. So basically, like, no matter what graph you're given, you should be able to plug in points at the very minimum, understand if it's an open circle or closed circle. Again, if I were to graph the entire graph of y equals square root of x plus 5, it would go all the way down. But because of the restriction, I don't have that blue part, right? So again, you should practice all those problems, right? Like, given a function, can you really give me something like this? Like the exact graph here, right? So you need to be able to identify both types of graphs and then the domain over each graph, right? So like this guy here and this guy here. Okay, all right, there we go. So that is, it's one example. Again, you gotta be familiar with all types of graphs, be prepared for anything that could go here or here. But in any case, just be able to graph a piecewise function, right? Okay, so there's that guy there. Okay, and again, remember that these values, these ranges tell you what numbers to plug in, right? So that's one way to do it. Okay. All right, gonna pause. Okay. And again, this is the thing, guys. You gotta make sure, like, no matter what type of function you're given, you need to be able to go both ways, right? So for example, like, let's say I had something like this. Again, it could be any type of function, any function. Okay. So again, like, given the equation, can you really write down what f of x is? So like, let's say that this point here was -3, 3. And let's just say that this point here was -3, -3. Okay, and so this is going to be like the graph y equals x, but then this is going to be for when x ranges from, oh, you got to be careful, guys. Be careful, that's a positive figure right there, yeah. Okay, so there we go. So it should be 3, 3, now it's right. So let's say you should be able to understand that this is going to be y equals x from -3 to 3. Like, you need to be able to get the equation of that one. Okay, so if you have like 2 points, be able to get the equation, understand that there's no open circles. And then something like this, like let's say this is a closed dot right there. You need to understand that that graph is being graphed for values of x that are greater than or equal to 3. And let's say right? And then let's say I had this point right here. Let's say I had 4, 1. So that would be the graph y equals the square root of x minus 3. Because it's really like the graph of y equals the square root of x moved to the right 3. Okay, and I noticed that if I were to plug 3 into here, I would get 0. If I were to plug 4 into there, I would get 1. So this is just an example, but again, you got to be prepared for anything, right? So what I'm saying is you got to be prepared for any function they give you here. Okay, so any function they give you here, you gotta be able to give me something like this, okay? So that's the idea. So make sure that you can do that, like no matter what function you originally start with, you gotta give the exact piecewise function. So you should do, right, review your homework problems, make sure that you understand, given a graph, how to get the piecewise function here. Okay. Okay. What else here? You gotta be able to understand, like I'll just give you the basic idea here. So again, I'm not gonna give you the exact thing, but again, if I just do this in general terms, so you gotta be able to tell me things like this, right? Like you have an x-intercept here where the x-intercepts occur at a, 0, and then the other x-intercept occurs at b, 0. So those come from the top, and then you gotta be able to say, all right, well, what about the vertical asymptotes? There's one vertical asymptote at x equals c, and then there's gonna be another vertical asymptote at x equals d. And then what about the horizontal asymptote? Okay, horizontal asymptote, well, again, I mean, if you really wanted to multiply all this out, you could. This would be x squared plus, what is this here? It's going to be x squared, and then, it's going to get a little intense here, like minus bx minus ax plus ab. All right, divided by x squared. This is going to be something similar. Minus dx minus cx plus cd. If you notice here, when you're looking at horizontal asymptote, everything has to do with the highest powers on the top and the bottom. Here they're the same. Whenever the powers are the same, you take the coefficients in front. So here, the horizontal asymptote, what is it going to be? It's going to be just y equals 1. Okay. All right, so I got, from that information, 2 x-intercepts, vertical asymptote, horizontal asymptote. What else am I missing? The y-intercept. And remember, y-intercept is when you always plug in x equals 0. So the x-intercept is going to be 0, comma, AB divided by CD. Okay. Okay. So again, this is just the main idea, but again, you got to be prepared for anything. Okay, so basically, if the function has like all letters in it, can you really give me all the information from a theoretical standpoint, right? Okay. Okay, next thing here. Again, this is the thing. You're gonna like let's look at this here. Something like this. Okay. Let's say you had something here. Okay. And for example, I'm just going to make an example up here, something like this. Okay. Okay. Okay, so here's an example, and let's just say that this was a 3 here. Okay, let's just say that this is going to be the point 5, 4. Okay, guys, sorry, so I got to redo this here, so here we go. So I'm making this a little easier here. So let's, something a little easier here. So let's say, I'm going to make this a little easier. The other one was a little too complicated. So let's say I have something like this. Okay. Okay, so let's say I have this, and let's say I have this. So if you remember in class here, let's just say that this is the point 3, 0. Again, when you're looking at problems, this is a rational function, by the way. We're assuming it's a rational function. So again, if I were to write down f of x here, 3, 0. Like if I notice this crosses a 3, 0, you should automatically be writing x minus that value. I notice that when I plug 3 into that equation, I'm going to get 0. So that's going to be involved somehow. I notice that there's a horizontal. So that means the power on the bottom is going to be bigger. I notice that, there is a vertical at x equals 0. And I notice that these go opposite ways, right? Remember we did that one day in class where the rational function goes opposite ways. And so what I understand from that is that power needs to be odd, right? Remember, if it goes opposite ways, like near this asymptote here, the power has to be odd. We did that one day during class here. I'm not going to make it a 1, though, because I need a horizontal asymptote, so I'm going to make it a 3, okay? All right, so let's see if things are checking out. I got the y equals 0 because the power on the bottom is more than the top. Okay. And then I got, going through the point 3, 0. Okay. And then I got to be thinking, is that just it? Just x minus 3 divided by x cubed? Is there any other information here? So, what you do is, let's say that you got that graph. You want to think about, well, if I were to just graph this on my own, would I get the same thing, right? Well, let's see. Remember, how do you graph this on your own? Asymptote at x equals 0 makes sense. Asymptote at y equals 0 makes sense. There's no y-intercept. When you plug in x equals 0, it would mess up. If I were to plug in x is 3, I would get this. Okay. And that's basically it. And then remember, everything just has to follow. Everything just has to follow all the asymptotes, right? And again, this here is the only spot where it's going to cross the x-axis. Because if I were to set this equation of y equal to 0, that would be the only solution, right? So then it's like you just kind of take some test points, right? Like if I were to plug 10 in, and then I would get a positive number. So that would be somewhere over here. And then it would have to follow the asymptote. Okay. If I were to plug in something like 1, that's going negative. So it's doing the correct thing, right? So it's like that part of it checked out. And then it's like on the other side, you got to make sure that when I plug in a negative number, like let's say -5 into this equation, you're going to get a negative number divided by a negative. That's going to be positive. So I'm going to have some point over here. and everything has to follow the asymptote. So, and then we understand that it has to look like this. Right, so again, to be 100%, sometimes when you get the equation, it's actually best to try to think of how you would graph it after that and see if it matches up, right? So again, make sure that, given an equation, make sure that you can, get the function given a graph, right? So you got to be able to go the opposite way from here to here. So make sure that you can do that by setting it up. Really, the first step for that is to identify, the x-intercepts, the horizontal asymptotes, et cetera, and you should be able to write them down in the function. Okay. Okay, and then what else here? So, okay. So you also want to be able to graph like rational functions. So I'll give you an example, something like this. So just an example. Okay. Again, how do you graph a rational function? The first step is to graph the two asymptotes. So I'm going to have one at 7. And then I'm going to have one at -2. And then I'm going to have one at y equals 0. Okay, I have an x-intercept at -5. And then remember, you just have to follow, right? You can always pick test points. Like, let's say I picked a -3. You want to think about the sign, and that's going to go positive. So this is -5 right here. If I were to pick -3, that's going positive, and you got to follow the asymptotes, right? Let's say I pick something like -10. That's going to give you, like if I plug -10 into all three of these, that's going to give me 3 negatives. And the thing is, it's going to go down, but then it has to, again, approach the asymptote at the end. So if it goes through, you got to make sure you're approaching at the end. Always a good idea to get, let's say, y-intercepts. If I were to plug in x equals 0, I would get 5 over -14, or just a negative number. Remember, I went over this before. Whenever you have this situation, you're going to either see these s's or the u's. The only place I cross is at -5, so you're going to have, I can't do a u like this. I can't do one of the s's, so you have to have this u going down. That's the only option. Then let's say I were to pick something like a 10, you're going to get a positive number. And you always approach all the asymptotes, so then you're done at this point, and then you should also graph it in Desmos, okay? So again, no matter what function you get, given a function, you should be able to completely graph, and I would practice, all the homework problems on that. Okay. What else here? What else? Yeah, so that's that. Also, be aware, I'm going to do file new. Okay, and then the other thing here is it's like this. Make sure that you understand what oblique means. Like, for example, I'll just do one example here. Like, let's say I had something like this, right? What is this? This is the same thing as x plus 1 over x. And then it's like, okay, wait a minute. How do I graph this thing? Well, first of all, this graph is this. And the idea is you don't need this part to get the oblique. So, you need to be able to graph oblique asymptotes. And again, this part here tells you if you're above or below the line, right? When x is really, really large, you're going to have x plus a small decimal, so we're going to be above the line. When x is really negative, you're going to be at y equals x minus a specific amount, so you're going to be over here. So again, this part right here tells you if you're above or below the line. And then it's like, wait, I have a vertical at x, at x equals 0. Okay. And so when you're doing these here, you should be thinking, wait a minute, are there any x-intercepts, right? And here, the top never goes to 0, so there's none. Are there any y-intercepts? Meaning when you plug in x equals 0, do you get a point? And that's a no, so there's none. Okay. This is the thing. Do we ever cross? Remember, you can. Let's just remember this real quick. Remember, you can cross oblique. You can cross oblique asymptotes. Okay, it's possible. You can cross horizontal. Okay, but you cannot cross vertical, so you got to remember that. So you can't cross vertical asymptotes. So really the test here is, let's see if we're going to cross this y equals x curve. Does the original graph ever exactly hit the the oblique asymptote here? And when we test this thing, we're going to actually get 0 is equal to 1. So here that does not work, so it doesn't cross. But again, you have to approach all the asymptotes. So, this is like a brick wall now, and the only way to approach all the asymptotes is like this. So yeah, you just gotta be aware. You gotta know how to graph, anything that has a linear asymptote, right? So that's the thing. So make sure you know how to graph linear asymptotes. Make sure you know what part to cross off. Make sure that for every graph, you're always thinking, what is the x-intercept? What is the y-intercept? What is the vertical asymptote? Are there any? In this case here, it was x equals 0. What is the horizontal asymptote? Are there any horizontal or obliques? Horizontal, there is none here. Because the only way you have horizontal is if the top and bottom powers are exactly the same thing. But there was an oblique asymptote, which was a line, and that was the line y equals x. Okay. So that's the idea. So every single time you're graphing a rational function, make sure you're including all those things. Don't forget any of those: x-intercept, y-intercept, vertical asymptote, horizontal asymptote, oblique asymptote. Okay, then you can also always do test points, and whenever you have a point, you gotta always follow all the asymptotes, but make sure that you're also seeing, let's say if it crosses or not. Okay. Okay. All right, looks good. And that's all I'm really going to tell you for that. Just make sure that you can graph all rational asymptotes, no matter how complicated it is. So just make sure that you can, make sure that you can graph all types of rational functions. Well, that's what I mean. All types of rational functions. Okay. Okay. Anything else here? Yeah, and the only other thing I'm going to say, guys, is make sure you do all the word problems. You got to be able to express one variable in terms of the other. So in other words, like be able to express volumes in terms of the radius or areas in terms of x. So I would practice those problems, okay? So make sure you practice those types of problems, like expressing something in terms of another variable. And that's basically it, right? So again, at this point, I think it's really practice, but that's a good start. But really, you gotta practice, problems that are similar. Homework problems really help. But again, that's pretty much right, like somewhat what that's expected on the tests. I mean, nothing was exactly the same, but you got to know those same ideas. As it's kind of like a test review, right? All right, thanks. I'll see you guys on the test on Monday.